Hello everyone, my name is Professor Ian Robson and I am an astronomer. Astronomers have a fabulously exciting career, working in teams to study the universe in which we live, from the sun and planets in our solar system, the stars that make up our Milky Way galaxy, to the enormity of our entire universe. Let's start off close to home. The sun is our local star. It's really huge. You could fit 109 Earths across the diameter of the sun. It's around 150 million kilometers from us and about 4.5 billion years old. That's 4,500 million years old. While this sounds like a very long time, the sun is actually only in middle age and has lots and lots of time left to continue shining. Our sun is accompanied by 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. And there are lots of others much smaller bodies like asteroids and comets. The planets orbit the sun in a flat plane, like a disk. We can see 5 of them with our naked eye, but Uranus and Neptune are too faint to be seen without binoculars or a telescope. Stars come in a huge range, from really small, cool stars known as dwarfs, to average stars like our sun, through to much larger stars called giants. Some stars are very hot and shine with a white light. Sirius, Rigel and Vega are 3 of the easiest to spot in the night sky. A few stars are incredibly massive, yet they're cool, and these shine with a red light. They're called red supergiants. Betelgeuse in the constellation of Orion is the easiest example to see. Now, if our sun were replaced by Betelgeuse, then Mercury, Venus, Earth and Mars would all be swallowed up as the star is so large. Stars are born in clouds of cool gas and dust, but these are difficult to observe because the dust hides what we can see in visible light. But longer wavelength light, beyond red light, called infrared and far infrared, can penetrate through the dust and show us how stars are being born. I'm a far infrared astronomer, and some of my work has been to investigate the secrets of stellar birth. Our eyes can't see infrared light, so you need special telescopes and instruments for infrared astronomy, as we shall see later. Stars spend most of their lives steadily shining away, being powered by burning hydrogen to helium in their centers and releasing energy. When they get to old age, they can swell up, shed their outer layers and collapse to a remnant the size of the Earth. These are called white dwarfs, and this will be the ultimate fate of our sun. White dwarfs have an amazing density, equivalent to squashing a small car into the size of a sugar cube of about 1 centimeter cubed. Much larger stars, however, end their lives as supernova explosions, whereby they swell up and then blow themselves apart, possibly leaving behind a neutron star, an amazing compact object with an unimaginable density, like squeezing the sun into a sphere diameter of only about 20 kilometers. Alternatively, it may form a black hole, or just nothing at all but debris. But crucially, this supernova debris has lots of elements heavier than hydrogen and helium, and it is these elements that allow solid objects like planets and even life itself to exist. Without supernova, we wouldn't be here. Stars live in huge families called galaxies, each containing something like 1 million to 1 million stars. We live in the Milky Way galaxy, an average sort of galaxy and known as a spiral galaxy because of its shape. The universe is made up of billions and billions of galaxies, and is so vast it's pretty much unimaginable. The universe hasn't always looked the same. Indeed, we now believe that the entire universe came into existence as a hot Big Bang, some 13.8 billion years ago. We don't know for sure what will happen in the future, but this is what many people try and answer in modern astronomy in a key research field called cosmology. This is the study of the birth, evolution, and subsequent end of the universe itself. I was fortunate to be involved in a small way in showing that the universe started with a hot Big Bang. This was very early in my career. The project involved a small team of astronomers flying a far-infrared experiment under a huge helium-filled balloon from Texas in the USA. Why did we use a balloon? Well, we had to get above the water vapor in the Earth's atmosphere, because this absorbs a very faint signal from what is called the cosmic microwave background, a leftover remnant of the hot Big Bang we can see today. A space satellite would have been much better, but in those days, when space experiments were in their infancy, it was far, far too expensive, so we had to make do with balloons. This shows our experiment on the launch pad in Palestine, Texas, all ready to go at sunset. Here we see the launch, which was very smooth, But unfortunately for us, the balloon burst when it got to a height of 25 kilometers, and everything plummeted back to Earth, with the parachute unopened, but streaming behind it, and ending up in a dense forest. Now, incredibly, it all came down between three very tall trees. They caught the remains of the flapping balloon and parachute. The experimental package never hit the ground. If it had, it would have been totally destroyed. We were very lucky indeed. So we took the experiment back to London, mended it, and returned to Texas the following year. This time the balloon successfully went to 40 kilometers and everything worked just fine. That was a big relief. Astronomers use telescopes to investigate the universe, and the bigger the telescope, the better. A larger size means more area to collect light, which means you can see fainter and more distant objects. Larger also means, in principle, that you can see more details. But here we hit a major snag: the Earth's atmosphere. The Earth's atmosphere is turbulent, meaning it moves around a lot, and in so doing it smears out the light, therefore hiding the fine details. Astronomers therefore build their telescopes on sites where the atmosphere is less turbulent, mostly remote and mountaintop sites, such as Kitt Peak in Arizona that we see here on the slide, La Palma in the Canary Islands, Mauna Kea in Hawaii, and Cerro Paranal in the Atacama Desert of Chile. For infrared and far-infrared astronomy, the Earth's atmosphere also absorbs some of the light from space, and so we need to get really as high as possible, typically to very high mountaintop sites. The world's best infrared telescope, the United Kingdom Infrared Telescope, or UKIRT for short, was built on the summit of Mauna Kea, a dormant volcano on the Big Island of Hawaii. Mauna Kea is almost 14,000 feet high, or 4.2 kilometers, and its summit is a real mecca for telescopes. Mauna Kea means White Mountain, as we shall see later. On this slide, we see the summit area of Mauna Kea, showing the vista of some of the world's largest optical, infrared, and far-infrared telescopes. This is a truly fabulous location, and one where I spent many years of my career. Now, at 14,000 feet, the oxygen content of the atmosphere is much less than at sea level. This means you need to acclimatize to get used to being at this height and to work safely. Also, you need to be very careful in making decisions, as your brain just isn't working as well as normal, but you don't realize it. In the early days of observing, it was fun to go outside and look at the sky, and although it was very dark, the lack of oxygen in my brain meant I couldn't see very faint stars. Here you see the constellation of Orion as you might first see it. However, taking a deep gulp of oxygen from an oxygen mask in order to feed my brain meant the sky just lit up and I could see so much fainter stars. This was really cool, sort of mind-blowing. You might be surprised to know that even at these heights it can snow at any time of the year, even in summer in Hawaii. This is very surprising indeed, as Hawaii is close to the equator and is usually thought of as a location of golden beaches and year-round holidays. After a heavy snowfall on Mauna Kea, the local Hawaiians drive up to the summit to make snowmen and carry them back down to the beach in their pickup trucks. Just crazy. However, for us astronomers trying to do our work, the snow can be a real pain. Of course, you'd really like to have a telescope in space, but this is hugely expensive, and the size of the telescope is limited by what can be launched. The very famous Hubble Space Telescope has done a brilliant job for the past 30 years. The successor to Hubble, the James Webb Space Telescope, was launched on Christmas Day 2021. This is a large infrared telescope and will probe the innermost secrets of star formation and the earliest galaxies formed in the universe. It's a real triumph of engineering and is going to be tremendously exciting. I'm looking forward to its discoveries, especially seeing the very first stars and the very early galaxies. In 1992, I was fortunate to be appointed director of the James Clerk Maxwell Telescope, or JCMT. This is the world's largest far-infrared telescope, with a 15-meter diameter collecting surface, and like UKIRT, is at Mauna Kea, as you can see from the picture. The JCMT was purpose-built to investigate star formation and very distant galaxies generating a huge amount of new stars in the early universe. In 1997, a fabulous new instrument, built at the Royal Observatory Edinburgh and called SCUBA, was installed on the JCMT. It was the world's first camera for these far infrared wavelengths, So for the very first time we could take pictures, and this was a huge breakthrough. SCUBA is the large orange cylinder you can see on the JCMT platform. This contains a detector that converts the incoming far-infrared radiation from the cosmos into a measurable signal. This detector has to be cooled to extremely low temperatures, less than 1 degree above absolute zero, which is minus 273 degrees Celsius. This requires a lot of innovative technology. As director, I could use the JCMT once a month to make my own observations. One night, when most of my supermassive black hole galaxies were not visible, I thought it'd be really cool to observe the M16 Eagle Nebula with SCUBA. The famous Hubble image of the Eagle Nebula is shown on the left, while on the right is my SCUBA image. It turns out that the bright spots on the SCUBA image are not the same as those seen in the Hubble picture, but in fact are the darkest and densest regions. These are the cold cores where dust and gas are coming together to form new stars. They're completely hidden from Hubble. This was a new discovery and very exciting, and is a good example of the importance of far-infrared astronomy. The Big Island of Hawaii, the home of Mauna Kea, has active volcanoes, albeit on a different mountain to Mauna Kea, a mountain called Mauna Loa, meaning Long Mountain. These volcanoes occasionally erupt and can be seen while observing at the telescope. Here you can see the volcano erupting on Mauna Loa, as seen from Mauna Kea, and also lava flowing down the flanks of the mountain along with the Southern Cross star constellation, which is really beautiful indeed. But you can go one better, as on occasions you can get really close to the lava flows, both by day and even more spectacularly at night. This is just brilliant and something never to be forgotten. One year, my wife and I decided to hike closer to the volcanic vent for a better view. But as we got close, it erupted right in front of us, and so we had to beat a hasty retreat as we were showered with ash and glass fragments called Pele's hair, named after the Hawaiian goddess of volcanoes, Madame Pele. Here we see the 3 plumes of lava, ash and steam. Exciting times indeed. On another occasion, my colleague and I decided to make an early morning hike to get really close to where the lava was flowing into the sea. As dawn broke, we arrived at the uniform black sand beach made by the lava and managed to get really close. And it's true, the lava is so hot that a stick bursts into flame before it touches the lava. Although I've had a fantastic time doing astronomy, I actually haven't set out to be an astronomer. I wanted to be a fast jet pilot for the Royal Air Force. But my eyesight failed when I was 15, and so that was the end of that. However, in Hawaii, I had the opportunity to learn to fly. This is the view from my plane flying over the active vent of the volcano. You can just make out the red lava at the right-hand side of the vent next to the smoke. Astronomy has been a fabulous time for me. Would I do it again? You bet I would. Working in teams with fantastic people is hugely rewarding, and discovering secrets of the universe is just truly awesome. Although, as I said, I didn't figure on becoming a professional astronomer, I had been a keen amateur astronomer and was fascinated looking at the stars and especially the moon through a small telescope, something I still enjoy and I recommend it to everyone. There is something just magical seeing the craters and mountains in sharp shadows. I was brought up in a mining village in County Durham in the northeast of England, and none of my family had ever gone to university. In spite of not doing well at school, I was very fortunate to be accepted at a brilliant university department, Queen Mary College Physics in London. At the end of my degree, I was privileged in having the opportunity to do astronomy research on an exciting and brand new topic, observational cosmology. This was too good to miss, and as they say, the rest is history. So with hard work and a bit of luck on your side, there's no limit to what you can achieve. I hope you enjoyed that brief overview of my life as an astronomer, and if you want to see more about my exploits, you can Google YouTube Professor Ian Robson, Confessions of an Astronomer. Thank you.